Okay, Bismillahirrahmanirrahim and Assalamualaikum warahmatullahi wabarakatuh to our beloved lecturer, okay, and our friends. Okay, today I would like to introduce about the project for our task in the subject renewable energy, that is micro hydroelectric power project. Okay, this is our group members. First of all is Muhammad Adib bin Yunus. Second, Muhammad Amirul bin Muhammad Tai. Third, Amirul bin Arifin. And I am Amirul bin Arifin. Okay, today I would like to share about our project problem statement. Okay, first of all, several Oransley families made their homes in the vicinity of waterfalls that were 570 meters in height, 950 meters in length, and had flow rates of 20.5 liters per second. But organization that provides community services contacted and appointed a member of your team as a technologist and hydro specialist to assist with the design and construction of an appropriate hydro system utilizing a generator that they finance and one RAM generator from Italy. Okay, for the introduction of this project. Okay, first of all, small hydropower plants with an installed power generating capacity of less than 100 kilowatts are known as micro hydropower system kilowatt in kilowatt. No major dams or water storage reservoirs are created, and no land is inundated in many micro hydropower installation. Okay, for the turbines type selection, this is the hydro turbine generator that we use in our project. So this is the description of the component that have in this turbine. Okay, first of all, voltage 230 or 400 volt. Okay, second, 30 until 550 kilowatt Pelton turbine. Third, head 30 until 600 meter. 4, frequency 50 until 60 Hz. And lastly, model Ecowatt Hydro TPA or 1 RAM.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adi bin Yunus, CN200161. So today I'm gonna explain about total house. So based on the questions, given is head cross is 570 meters and a flow rate is 20.5 liter per second. And the total load demand for each house that we calculate before is 3,295. So to calculate how many house that we can be supplied, we have to calculate the hydro turbine power HTP first. The equation for calculate hydropower is P is equal to mg hash net efficiency. So first we have to calculate efficiency. So our design efficiency is the efficiency for turbine will be 95%. So the efficiency for drive will be 93% and the efficiency for generator will be 85%. So if we times all the efficiency, we're gonna get 75.1%. Okay, next. So we continue. As the results, we get the low gross head 5,000 meter, 570 meters, and the maximum flow rate is 20.5 liters per second. So before we calculate the power net, the power, we have to calculate the head gross by multiple 0.9. So H times 0.9 is 570 times 0.9 is equal to 530 meter. So all the informations used to calculate the power. So we put all the information in equation. So 20.5 times 9.81 gravity times 513 times 0.751, and we're gonna get 77.478 kilowatt. So we get the HTP. So to calculate the total house can be supplied is we have to divide HTP to TLD. So 77.47 kilowatt divided by 3,295. So we're gonna get 23 hours that can be supplied. So that's all for me, Muhammad Adib. Thank you.
So the advantages and disadvantages of micro hydro system from based on our project. Firstly, advantages: efficient energy source, but the disadvantage is low power the summer months. Second, reliable electric source, but the disadvantages is energy expansion not possible. Third is no reservoir required, but the disadvantage is low power the summer months. Fourth, cost effective energy solution. There are the advantages, but the disadvantages is environmental impact. So, and lastly, the advantages is power for developing countries. Okay, this is our layout plan from water source, piping, turbine house, and supply load. Okay, as we can see here, we use the AutoCAD to design the plan of the what we call the micro hydropower. Okay, first we can see here head water pond. So this is dam. So this is the intake of the water that flow from this pond. So below is a penstock. The the water down to the powerhouse with turbines, pump, and generator. So in this place, we have the generator, turbine. So this is the place that we generate the electricity from the water flow. So this is tail water pond. So lastly, the part is dam. Okay, this is the single line diagram. Okay, as we can see here, this is our single line diagram for the what we call the project that we use, micro hydropower. So this is the diagram that show for our project. So first is generator. So 3 synchronous generator, Pelton turbine. So after that, DC circuit breaker must flow the circuit breaker first. This is the earth. So this is earth 2 AC SPD. So after that, we go through to the control distribution box. So this is the what we call the switch, or the we can manage the current. So after that, below the control distribution box is download. So after that, kilowatt hour meter. So this is the what we call the power that we use, the calculation of the how many kilowatt hour we use. So after that, main switch 62 ampere. So after that, RCCB 60 ampere or 20 milliampere. So In this part, we use the 2 times of the PVC. So after that, this is the what we call how many item that we use. So first, we can see here 6 ampere circuit breaker. So we use 7 item in this circuit breaker. 4 for 15 watt LED light, 3 25 table fans. Below this part is we use 6 ampere circuit breaker too. So 7 item we use too. 5 15 watt LED light and 2 25 watt table fan. Okay, so this part we use for spare. In addition, if we want to add another item for the project. Okay, so below this is 20 ampere. Okay, so we use the high ampere in this part because we use switch socket outlet, 13 ampere switch socket outlet, so the current might be high. So after that, 20 ampere too, we use 3 item. So this is the size of the PVC and the what we call the wire that we use. Okay, so in this 20 ampere circuit breaker, we use 2.5 millimeter PVC. For the 6 ampere circuit breaker, we use 1.5 millimeter PVC. So 20 ampere, we also standby the spare for the circuit breaker.
Okay, we go through to the next slide, which is the conclusion. First of all, my name is Muhammad Amirul bin Muhammad Tahir. My matrix number is CN200104. Okay, in conclusion, each member of the group comprehends the experiment's objective and has been successful in accomplishing them. The objective is to become familiar with and identify the essential components of renewable energy components, to specify the specifications and circuit connection of each component, and to design and construct according to the client's specifications and requirements. Okay, that's all from us. Thank you.